Hey people, so I'm going to do a reading, Getting Your Feet Wet with R, book that I wrote. It's by Amy Moore. The thing I like about this book is that if you run through the book, like say take a weekend and run through the book, you'll have an idea of how to use R basically. But anyway, let's begin. So power calculations. Power calculations are computed to ensure that your hypothesis tests are performed correctly. Specifically, you can ensure that your decision to reject or fail to reject is accurate most of the time. So there is a power calculation for every statistical method that ensures that your tests have a certain level of power or accuracy. Power calculations also help you determine how many subjects are needed for your study. The power of the test can be calculated in R for most statistical procedures. The R package, PWR, enables R to generate your power calculations. It is recommended that you revisit Chapter 1 and follow instructions on how to download the PWR package. Figure 4.1 contains the generic syntax for a student t-test. Generally speaking, your R code for the power of the test will contain the following parameters: sample size, effect size, power of the test, type of hypothesis test, and whether it is a one-sided or a two-sided hypothesis being conducted for the calculation. Figure 4.2 shows an example of a paired t-test. All right, so I'm not going to read it so you fall asleep. Okay, but all right, so let me explain a few things. First of all, power of the test is basically you ensuring that you get statistical significance. Okay, so in other words, you have like a sample size, it should be large enough to detect statistical significance, but it shouldn't be so large that it detects statistical significance where there is none, right? So you want the minimal number of people. And R is a program that generates that calculation. And R has different commands or different equations that are based off of statistics for each statistical method that you run. You see, when you do a sample size calculation and you put that in your scholarly project or dissertation, you should have a sense of what parameters you used to calculate your sample size. And I do want to preface this with sometimes you're not using traditional statistical methodology. There's so many ways to get the sample size calculation. I'm talking about the traditional way where you know you're doing a inference test and you need a sample size, okay? So here's an example of a two-sample t-test command. Basically, you have the power.t.test, and you put in your parameters, and it will generate for you the sample size, which in this case is 41.31968. Basically, you could round that to 42, right? But I typically, what I'll do is I'll buffer the number, and I have a percentage, a particular way that I buffer the number so that just in case somebody, their data can't be used, you're still covered, right? So this is just a quick tutorial on power of the test. This is what the book looks like in case you want to get it. Getting Your Feet Wet with R by Amy Moore. Thank you for listening.